So, question 6 should be pretty straightforward, but we'll just work through it. We've got the general form of a line through an intersection, pretty standard, and we want to show that the gradient of L is 1 plus k over 2 minus k. Now, let's just rearrange L. So, we have x minus 2y plus 5 plus kx plus ky plus 2k equals 0. We're going to leave the y's on this side and put everything else on the other side. So we have minus 2y plus ky equals minus x minus 5 minus kx minus 2k. I might just swap all the signs around. So let's actually, I might leave, swap all the signs around. So we've got 2y minus ky equals x plus 5 plus kx plus 2k. Okay, that looks a bit better. Now I'm going to factorize the y on the left hand side, so we get y brackets 2 minus k. And we're going to factorize the x. So it's x1 plus k plus 2k plus 5. I'll just bracket that out. I'm going to divide everything by 2 minus k. So y equals 1 plus k over 2 minus k x plus brackets 2k plus 5 over 2 minus k. Now, what we've done is we've put it into gradient intercept form, y equals mx plus b. So we know that the coefficient of x is going to be our gradient. Hence, the gradient is 1 plus k over 2 minus k, as we wanted. Now, let's just have a look at part I of b, and the rest is going to be pretty similar. We want the equation of the line that passes through M is parallel to 3x plus 4y equals 5. Now, if we've got 3x plus 4y equals 5, we need to find the gradient. So, we have 4y equals minus 3x plus 5, which means y equals minus 3 quarters x plus 5 quarters. Therefore, the gradient of the line is minus 3 quarters. But we already know the gradient of the line is 1 plus k over 2 minus k. So, we have 1 plus k over 2 minus k equals minus 3 quarters. We'll just cross multiply. So we get 4 plus 4k equals minus 6 plus 3k. We'll just rearrange, and we get k equals minus 10. Now, to finish this question, all we need to do is actually just replace the k with minus 10. And if we just do it to this y equals mx plus b form over here, we get y equals, well, we know the gradient is meant to be minus 3 quarters. And then if k is minus 10, we've got plus minus 20 minus 15 over 12. Okay, and we can just simplify that to minus 5 quarters. And that's the answer to part I. The rest of the questions should be pretty easy. Just need to find the gradient of each of these equations, equate it to the formula for the gradient that we found to find k, and then sum back into y equals mx plus b. And that should be it. Here's another good question. I actually haven't read it yet, but we'll just work through it together. So, firstly, find the point of intersection. So, if we have x plus y minus 2 equals 0 and 2x minus y minus 1 equals 0, call this equation A and equation B, and we'll just add equation A and B together. We're left with 3x, y's cancel out, minus 3 equals 0, and we see pretty easily that x equals 1. We're then going to sub back into, let's say, equation A. Doesn't matter, but might be a bit easier. So we get 1 plus y minus 2 equals 0. So y is going to be equal to 1. Okay, so the point of intersection, therefore, is the point 1, 1. Next part, we need to show that it satisfies the equation x plus y minus 2 plus k, 2x minus y minus 1 equals 0. So all we need to do is sub in. So we get 1 plus 1 minus 2 plus k bracket 2 bracket 1 minus 1 minus 1 equals 0. Okay. Now over on the right hand side we get 1 plus 1 minus 2 plus k bracket 2 minus 1 minus 1. And let's see, all of this tends to 0, and all of this in the brackets is just 0, and that equals 0. Good, so left hand side equals the right hand side, satisfies the equation. That's easy. Now, find the equation line through P and Q using the coordinates of both P and Q. So, what it's asking us to do first is firstly find the gradient of PQ. So, gradient of PQ is going to be difference of the y's. So we have 1 minus 2 over the difference of the x's. 1 minus minus 2, which is negative 1/3. And we can use point gradient form. So we have y, we're going to just use point P because it's a bit easier. Y minus 1 equals negative 1/3, brackets x minus 1. Let's turn it into general form just to practice. So multiply everything by 3, we get 3y minus 3 equals minus 1 brackets x minus 1. Expand, 3y minus 3 equals minus x plus 1, and we'll move everything over this side to make x positive. So we have x plus 3y minus 4 equals 0. Excellent. So now we also want to do it without using the coordinates of P. Now, in order to do this, we know that the line must satisfy x plus y minus 2 plus k bracket 2x minus y minus 1 equals 0. And Q must satisfy this equation as well because it lies on this line. So if we sub in Q, we get minus 2 plus 2 minus 2 plus k 2 brackets minus 2 minus brackets 2 minus 1 equals 0. Let's see, they cancel out, so we get minus 2 plus k brackets, that's minus 4 minus 2 minus 1 minus 7 equals 0. That was correct. So we get minus 7k equals 2k equals negative 2 over 7. Now, we then push that back into our equation. So we get, I need to find room here, x plus y minus 2 plus minus 2 sevenths 2x minus y minus 1 equals 0. Let's just multiply everything by 7 to get rid of that fraction. So we get 7x plus 7y minus 14 plus negative 2 brackets 2x minus y minus 1 equals 0. Then we're going to expand, so we get 7x plus 7y minus 14 minus 4x plus 4 plus 2y plus 2 equals 0. Okay, hope you're following me here. So we have 3x plus 9y minus 12 equals 0. And notice that we've got a common factor of 3. Divide everything by 3. We have x plus 3y minus 4 equals 0. And it matches the equation we had before. So we have two ways of doing it. We can find the point of intersection, find the gradient, point gradient form, or we can use our little formula for the equation of a line that passes through the intersection of two other lines, sub q in, find k, replace. It's up to you to work out which method is better for you. Thanks.